Hi, my name is Muhammad Adnan Samad. Today, I'm going to present my research article named Advanced Control and Optimization Strategies for a Two-Phase Interleaved Boost Converter. So my name is, I told you my name is Muhammad Adnan Samad, and I'm working in Fargana Polytechnic Institute. So while starting, so I must tell you something about the main part of my paper, that is abstract. So boost converters are being used in almost every field of control systems. Like it ranges from electrical vehicles, solar system, renewable energy resources, and many more. But there is some sort of limitation while we use boost converter. So for the sake of those limitation, we can overcome those sort of limitations. The limitations can be in the form of efficiency, in the form of we can get a better step response by using a multi-stage interleaved boost converter. So in this paper, we had actually used interleaved boost converter with a two-phase system. And finally, we had presented a novel control methodology, that is MPSMC, which includes MPC and SMC in order to control this sort of two-phase interleaved boost converter. So the idea is twofold. Firstly, we will use the benefits of two-phase interleaved boost converter over single-phase simple boost converter. Then we will apply a novel control technique, that is I already told you, MPSMC, to enhance the step response of this sort of converter for the sake of using it in like any sort of applications. And finally, we had presented some simulation results that will verify the response of a simple converter without any sort of controller and with controller. So first of all, I had discussed introduction. In introduction, we had derived a simple boost converter. We had just given the detail of simple boost converter. Then we had a detailed derivation of two-phase interleaved boost converter. So the main thing is there are a few limitations, as I told you earlier, while using simple boost converter. That can be a voltage range, efficiency, EMI, and current limitation, and obviously the control complexity. So by using a two-phase interleaved boost converter, we can overcome all these issues. So this is the main theme of our paper. And finally, the control for which we are using MPSMC. So in the introduction part, we had presented a detailed discussion of a two-phase IBC, that is formed by using two boost converters in parallel to form a two-phase interleaved boost converter. And for the sake of simplicity, we have taken only the CCM mode, continuous conduction mode. So figure 1 is simply the figure that is a simple two-phase interleaved boost converter. Then we have 4 more figures that shows the 4 states of this sort of converter. In the first state, both the transistors Q1 and Q2 are on, and the next 2 figures are one transistor is in the on state and one is in the off state. And finally, the final and the fourth state is when both the transistors are in the off state. So that we can readily see in figure 2, 3, 4, and 5 respectively. So what we had used its state space modeling. So we had model in a state space like a representation, and we have derived its equations that we can readily see in our paper. So after this derivation, we will jump towards control and design methodology. So this is the main part of our paper, of any research article, like how we are controlling and designing the methodology section. So in this, we will firstly present the proposed controller design. So obviously the plant will be a two-phase interleaved boost converter. Then we will have an MPC, and then we will have an SMC. So MPC is being used in the outer voltage loop, and SMC is being used in the inner current loop. So we can see in the figure, like the output is like fed into the input of MPC, and then finally the MPC's output is being fed into SMC, where we can just actually we are trying to make it equal to the reference what we had provided. So that is the main theme of our paper. So we are using these two techniques. So we are aiming to use the advantages of both techniques, MPC and SMC, as we had already told some sort of we had already discussed some sort of you can say limitation in the form of like handling non-linearities, and if we have large disturbances, so we need some sort of control that will cater all of these issues. So there can be an EMI issues, there can be increased losses in high frequency applications, slow response to load changes, and limitation in handling varying input voltages, complex design, and finally the excessive chattering. So the excessive chattering is the main issue that is being solved by using SMC, sliding mode controller. So the main theme is obviously very like presented in detail, that we aim to use the advantages of these both techniques, MPC and SMC. So here is some detail. Like the outer MPC loop is responsible for the generation of a precise reference current. So we are generating a precise reference current by the use of MPC, model predictive control. Meanwhile, the inner SMC loop attracts the current to its designated reference point. So the main thing is we need to track our current to the designated point. Finally, arranging control technique in a way to achieve the best possible system response by the use of these two techniques. So simply by managing the advantages of these both techniques. So this is the main theme of our paper. Then we had defined our control problem. Like we have taken the inductor current as an error element, and the main equation is formulated in equation number 3. Like the error is equal to the reference value minus what we are getting. So now the objective is simply like we need to minimize this error. For this, we had chosen these values as given in table 1. Then we had presented some detail of model predictive control and slide mode controller. So here is a flowchart in figure 7 that simply like shows the steps included in while we talk about MPC, model predictive control. Firstly, we need to develop a state model. Then we need to measure all the states of the system. Then we need to minimize the cost function over the prediction and control horizon. We have two main things, the prediction horizon and the control horizon. Then we will check for the new measurements, and finally it will end, and it will continue in a loop until we get our desired response. So after using the benefits, the advantages of MPC, we can now use SMC for the sake of more robustness and resilience. The SMC has emerged as a dependable control technique for attaining desired system performance in the presence of especially uncertainties and disturbances for what we are using DC to DC boost converter. So as we had already suggested, the SMC is incorporated in the inner loop where the control signals are produced using the SMC law. This is the detail of SMC, and the main thing is this controller ensures the both phases operate in synchronization, maintaining balanced operation and minimizing the output voltage ripple. Finally, in the section 4, we had presented our results and discussion. So we can readily see like the figure number 8 is without any controller, and the figure number 9 shows the step response by using MPSMC, the novel proposed controller. So in table 2, we can compare the step response parameters for these both two. Like we can see, like without controller, we are not achieving our goal. Like our final value is not as we need to get in unit step function 1. But in our case, like in our controllers, MPSMC, we are attaining this value. So this is the main thing what we need to do. Like the other step response parameters, rise time, settling time, percentage overshoot, we can also see these are also much better in case of our proposed technique, and these are not as optimal as it should be without when we are not using any sort of controller. Further, the effectiveness of this controller is also verified by using like some sort of disturbances. Initially, we had used a square wave as a disturbance. Then we had used a unit step function as a disturbance. So in both the figures, figure 10 and figure 11, we can readily see that there is a lot more work that need to be done when we are not using any controller. So when we had used the controller, the suggested one, MPSMC, we can see like in case of disturbances, the disturbance is not affecting it much. So this is the main theme of our paper. So these two responses, disturbances, also verifying the use of our proposed controller to enhance the quality, to enhance the step response parameters, as we had already mentioned for the given two-phase interleaved boost converter. So to conclude, we can just say like the main thing is like we are going into two domains. The first one is we are using the advantages. Like the main thing is we are increasing the efficiency by using a two-phase instead of using a single-phase boost converter. After after this, the second main thing is we opt new controller technique MPSMC, which actually gives a better response in the while we have some disturbances and while we have some non-linearities in our system. So that is a combination of two techniques what we are using nowadays, like MPC and SMC, for controlling a two-phase interleaved boost converter. So a two-phase interleaved boost converter is widely used in different applications because the main thing is it can share current load between phases and ripple the output voltage. So it is just sharing the load between both of the phases. So the control strategies for such converters are, however, very challenging. So the main thing is to control a boost converter or an interleaved boost converter is not so easy because of its non-minimum phase behavior. So we need to use some sort of technique that will cater all of these issues regarding the response of these sort of converters. Like while we use a simple basic conventional techniques, PAD, you can say like and many more techniques, like we use Ziegler-Nicholas method to find the values, the parameters of PAD, KP, K, and KD, like the proportional, the integral, and the derivative gain. So these are old-fashioned techniques. So we need some techniques that will cater all of these things and give us the solution, the optimal one, the optimal solution of our system. And finally, our future work is obviously to increase the stages in our interleaved boost converter. Like we can use 3, 4, or 6-phase interleaved boost converter to enhance the efficiency at a more higher level. And some of applications can be, we can also use some other sort of control techniques, like we can also use ADRC, active disturbance rejection ratio, active disturbance rejection ratio control, we can use ADRC, and we can also use the composite model, like the different composite one. Like we had used a composite model MPC and SMC in this paper, and we can use some other sort of model, like we can use ADRC with MPC, we can use ADRC with SMC, and we can even use some more sort of technique. Finally, in the acknowledgement section, there is no funding for this particular research, and we tried to present some sort of latest and well-connected references with our article. And at the end, there is some biography, including me and my co-authors. So this is all about our paper, Advanced Control and Optimization Strategies for a Two-Phase Interleaved Boost Converter. Thank you so much.